6.4 graphs of trigonometric functions. So we have three different types of trigonometric functions. We have a sine, a cosine, and a tangent. So we're just going to go through sine and all of its attributes. So first of all, this is the equation for a sine function. It is very much like all of our other transformations. A, B, C, and D do the same things that everything else did in all of our other functions. But we have some different names for them. So first of all, the midline is this middle section right here where it becomes symmetrical. And it is our D value. It is our vertical translation. We have what is called the amplitude. In a normal sine function, the amplitude is 1. It's the distance between the midline and then the max and the min. These are our maximums and our mins. Our amplitude in the equation is this A value. It's how much it stretches it up and down. Alright, we have what is called the period. So a period length for a sine function is one full cycle. So a full cycle for a sine function starts at the midline and then it goes up, comes back down, hits the midline, hits the minimum, and then it ends here when it hits the midline again. So for a normal sine function, our period length is 360 degrees, or it is 2 pi. And that's going to come up often in various portions of this course between this unit and next unit. So it's just something you kind of have to remember. And the last thing we have is this C value. It's called the phase shift. That would be if we move our graph from left to right. Okay, so let's use this information to figure out all of this stuff about the sine function. So we're going to determine the period, midline, amplitude, range, phase shift, blah, 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 and an equation. So we're going to start with the max. So the maximum is 5. The minimum is 1. This will help us find our midline. To find the midline, we are going to add them together and divide by 2. So 5 plus 1 is 6, divided by 2 is 3. And I'm just going to draw that in to make sure it looks right. And it does. It's right down the middle. We can now find the amplitude. The amplitude is going to be the max subtract the midline. Or you can take the midline and subtract the minimum. Both work. Either way, you're going to get 2. You can also count that. 1, 2. 1, 2. Alright, let's do the period length. So a sine function starts at the midline, it hits the midline again, and ends when it hits the midline after one full cycle of up, then down. So that is at pi over 2. So my period length is pi over 2. Something that can be useful to us is to figure out what each line is worth on this graph. So if 4 lines is pi over 2, I would take pi over 2 and divide it by 4 and know that every line is worth pi over 8. So just become good at doing that. Okay, let's make an equation. So I'm going to write out A, B, C, and D. And I like to start with the D value because it's my midline. So D is 3. And my amplitude is my A value. So that is 2. Our C value is our phase shift. So for a sine function, it's supposed to start at the midline and go up, which is exactly what we have. So there is no phase shift. And the last is the period. So this is the hardest one to figure out. So to figure out the period, you're either going to do 2 pi, or your B value. You're either going to do 2 pi divided by your period, or it's going to be 360 divided by your period length. Because it is a fraction of 1 over B, just like all of our other lessons have been. So it would be 2 pi divided by pi over 2. So this is the same as 2 pi times 2 over pi The pi's will cancel and we are left with 4. So my b value is 4. So my equation would be y equals 2 sine 4x plus 3. So there's my equation. We just plug it into that formula for C and D. Let's do a cosine function now too. So cosine is very similar. The only thing that's different about a cosine is that it starts at your maximum and it ends at your maximum. So it still hits your minimum, but it goes from down or up, down, up. Okay, so for this one, I will start with max and min. So my maximum is 5. My minimum is -3. This will help us find my midline, which is 5 plus -3 divided by 2, and we get 1. And that looks good. So I'm going to go over here because we're making an equation at some point. That lets me know that the value of D is 1. So we're already part of the way there. Now we can find the amplitude. To find the amplitude, I'm going to take the maximum and subtract the midline, and I get 4. I can also count 1, 2, 3, 4. So my amp is 4. Now I'm going to do my period length. So something that is useful is to figure out how much each line is worth. So I have 1, 2, 3, 4, 5, 6 until I hit pi, which means that each line is worth pi over 6. So that's helpful. When we are finding our period length, we can either go from start to finish, we can go peak to peak. There's so many different ways. And it doesn't matter if we go a start of a cosine to a start of a cosine or a start of a sine to a start of a sine, it's going to be the same amount. So if I start here, my period length is going to go over 1, 2, 3, 4, 5, 6 pi's. 6 pi over 6's. So that is actually just pi. So our period length for here is actually just 1 pi. Or if you want to think about it as 6 pi over 6, you can, but it is 1 pi. So our b value is going to be 2 pi divided by pi. These cancel, and we are left with a 2. Now this one does have a phase shift. It's supposed to start at the maximum for a cosine, but that didn't happen. The cosine function started here. So it looks like it's halfway between that point. So that would mean it's, we could make half points for all of this. So if I made half points, it would be pi over 12. Half of pi over 6 is pi over 12. So this is actually going 1, 2, 3, 4 pi over 12s. Just kidding, it should be 5. I counted that wrong. 1 pi over 12, 2 pi over 12, 3, 4, and 5 pi over 12. So I have a phase shift of 5 pi over 12. So that's going to go in, and because we're moving it to the right, it is a positive. So let's make our equation. So we have y equals a cos b x minus c plus d. So we have y equals 4 cos 2 x minus 5 pi over 12 plus 1. So that is our equation. So if you've taken Foundations 30, this is something you've already done. And if you want actually more videos on this, you can go to the unit in Foundations 30 on sine and cosine functions. What will be new for everybody, however, is tangent functions. So this is a tangent function. because when you type in tangent of 90, you get an asymptote because it's undefined. It has this funky shape. So it has a period of pi. Half of it's on this side, half of it's on this side. And then we have kind of this point halfway between where it hits 1 and -1. So we don't really have a midline. We do still have stretches and phase shifts and all of that, but it is a little bit different. It looks a little bit different for these. So let's look at this one. So for this graph, let's see how much each line's worth. So we have 1, 2, 3, 4, 5, 6 lines makes pi, so each line is worth pi over 6. And we have an asymptote here and here, so we're going to think about that as pi over 12s because we're going halfway through the line here. So we have half. So on that side we have 3 pi over 12s, and on this side we have 3 pi over 12s. Altogether my period length is 6 pi over 12, which is pi over 2. So that is our period length. Our midline is still the midline, so it's 0. A phase shift, we would notice a phase shift if this intercept was anywhere besides at 0. So we can make an equation to figure out where our x-intercepts are going to be. So the general equation for our x-intercepts would be x equals 0, and then it's going to go every whatever our period length is. So our period length is pi over 2. So it'll be plus pi over 2 times k, for k is an element of z. That's not how you do it. There we go. So that's kind of our general equation for a x-intercept. We can also do a general equation for our asymptotes. So the general equation for our asymptotes is that we have, so for half of our period we're going to have an asymptote, every half of our period. So our first one right here, half of pi over 2 is at pi over 4. So our first one's at pi over 4, and then we're going to have an asymptote every period length. So plus pi over 2 k, where k is an element of z. So there's an equation for our x-intercepts and our asymptotes, general equations. That's something you're going to have to be able to do. Alright, let's make an equation. So a, b, c, d. We know there's no phase shift because it starts at 0 and 0. My midline is at 0, so there's no d value. Our b value for a tangent, instead of doing 2 pi divided by the period, we're going to do pi divided by the period. So we have pi divided by pi over 2, which is the same as pi times 2 over pi, and they cancel, so our b value is 2. The next thing that we will have to do is we're going to see if there's a vertical stretch. So what I'm going to do is I'm going to look halfway between my intercept and the asymptote, and I'm going to see if it hits a point. And this one looks like it hits 2. And down here it looks like it hits at -2, and it's about halfway. So that means my stretch is 2. So the equation for this function is y equals a tan b x minus c plus d. We're going to write it as 2 tan 2 x. We do not have a c and we do not have a d. So there is our tangent functions, and that is an overview of each of those things. Alright. I think it's a sign that we move on to the next lesson. Ha 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 ha. You know I'm funny and that you want to laugh. I don't care if it's at me. Okay, bye!